When people hear the phrase national infrastructure, they often picture something physical: power stations, roads, railways, water pipes, mobile phone masts. What they usually do not picture is monitoring rooms, data feeds, dashboards, control systems, incident protocols, and quiet coordination between dozens of organisations. In the UK, national infrastructure is not protected by a single authority or system. It is protected through a layered network of operators, regulators, government bodies, and technical systems that work continuously, mostly out of public view. This video explains how UK national infrastructure is monitored and protected in practice. It is not about emergencies or dramatic failures. It is about how normal operations are kept stable, resilient, and recoverable at national scale. National infrastructure in the UK includes energy, water, telecommunications, transport, data centres, digital networks, and supporting systems like timing, location, and control technologies. Each of these sectors is operated by different organisations. Some are public, some are private, some are regulated monopolies, some operate in competitive markets. There is no single control room for the country. Instead, stability emerges from coordination. Monitoring begins with operators. Every infrastructure operator runs its own operational monitoring systems. In electricity, this includes real-time visibility of generation, demand, frequency, voltage, and network stability. In water, it includes flow rates, pressure, quality measurements, reservoir levels, and treatment plant performance. In telecommunications, it includes network availability, congestion, latency, packet loss, and service continuity. In transport, it includes signalling status, vehicle movement, load, maintenance conditions, and safety systems. These systems are not designed primarily for government oversight. They are designed so operators can run their networks safely and efficiently. Protection starts with operational competence. If an operator cannot see what is happening in its own systems, no external authority can compensate for that. Operational monitoring systems generate large volumes of data. This data feeds into control centres staffed around the clock. Engineers watch trends, not just alarms. Small deviations often matter more than obvious failures. A slight frequency drift in the power grid, a gradual pressure change in a water network, a slow increase in latency across a mobile network. These signals allow early intervention. At this level, protection is about prevention. Most incidents are resolved before the public notices anything. Above operators sit regulators. Regulators do not run infrastructure. They supervise how it is run. Each sector has its own regulator with defined legal powers. Energy is overseen by Ofgem, water by Ofwat, telecommunications by Ofcom, rail by the Office of Rail and Road. These regulators require operators to meet resilience, reliability, and security standards. They do this through reporting requirements, audits, inspections, and ongoing engagement. Regulatory monitoring is slower and broader than operational monitoring. It looks for systemic risk, underinvestment, poor maintenance, and weak governance. Regulators are not interested in every minor fault. They are interested in patterns that indicate fragility. Technology plays a central role here. Operators submit structured data to regulators: performance metrics, incident reports, maintenance records, investment plans. This information feeds regulatory analysis systems. Risk models highlight where attention should be focused. Supervision is risk-based. Critical operators face closer scrutiny. Low-risk operators face lighter oversight. This allows limited regulatory resources to be used effectively. Beyond sector regulators sits government coordination. In the UK, responsibility for national resilience is distributed. Cabinet Office functions coordinate cross-sector risks. Departments retain responsibility for their sectors. Local resilience forums coordinate at regional level. This structure avoids centralized control while enabling alignment. Monitoring at this level focuses on dependencies. Energy depends on telecoms. Telecoms depend on power. Water depends on both. Transport depends on all of them. Failures rarely stay contained. Protection therefore requires understanding, interconnection. This is one of the hardest problems in infrastructure protection. Dependencies are technical, organizational, and contractual. Mapping them requires cooperation. Government plays a convening role. Information is shared under defined legal frameworks. Trust matters. Sensitive information must be protected. Operators will not share openly if data can be misused. This shapes how monitoring systems are designed. Cybersecurity is inseparable from infrastructure protection. Most infrastructure systems rely on digital control. Industrial control systems manage physical processes. These systems were not originally designed for hostile environments. They are now increasingly connected. Protection involves segmentation, monitoring, access control, and incident response. Operators monitor for anomalies, unusual commands, unexpected connections, changes in behavior. Cyber incidents are treated as safety incidents. Response is coordinated. Regulators require reporting. Government provides support. The goal is containment and recovery, not attribution, not retaliation. Protection also includes physical security. Sites are hardened, access is controlled, redundancy is built in. Single points of failure are identified and mitigated. Resilience is not just about preventing failure, it is about recovering quickly when failure occurs. This is why redundancy matters. Multiple power sources, backup communications, failover systems, geographic separation. These decisions are expensive. They are justified by risk. Monitoring informs where redundancy is most valuable. Data centers are a critical part of national infrastructure. They support government services, finance, communications, and cloud platforms. They are monitored continuously: power usage, cooling, network connectivity, physical access. Data centers are regulated indirectly through planning, through energy policy, through security requirements. They sit at the intersection of digital and physical risk. International connectivity is another layer. Subsea cables carry most international data. They are monitored for faults and degradation. Repair capability is limited and slow. Protection relies on diversity of routes and providers. There is no single cable that must never fail. Resilience comes from multiplicity. Timing and positioning systems are often overlooked. Many infrastructure systems rely on accurate time: power grids, telecoms, financial systems. Timing disruptions can have wide impact. Monitoring includes time synchronization and fallback systems. Emergency response ties everything together. When incidents exceed operator capability, coordination escalates. Information flows between operators, regulators, emergency services, and government. Decisions are made based on shared situational awareness. Technology supports this: dashboards, secure communications, common operating pictures. Exercises test these systems. Failures are expected. Learning is continuous. After incidents, reviews are conducted. What was detected, what was missed, what took too long. Monitoring systems are adjusted. Procedures are refined. This is how protection improves over time. There is no final state of security. Threats change, systems age, dependencies evolve. UK infrastructure protection is deliberately pragmatic. It does not aim for zero risk, it aims for managed risk, acceptable risk, recoverable failure. This reflects reality. Perfect protection is impossible. What matters is whether society continues to function. Most of the time, it does. That is not an accident. It is the result of constant monitoring, coordination, and adjustment. Understanding this helps explain why infrastructure decisions look cautious, why change is slow, why redundancy is valued, why coordination matters more than control. This is how UK national infrastructure is monitored and protected in practice.